All right, so I am focusing on factoring out the GCF, which is the greatest common factor. And this is the first step you always try to do when you are factoring in general. So just to start with, what exactly is factoring? So factoring is reversing our multiplication. So it reverses the distributive property, and it's reversing any multiplication of polynomials. And we end up with writing things that are a product of factors. So product means multiplication, and then factors are just things that you multiply together. So you're turning things into things that are like added or subtracted, and now you're turning it into multiplication and writing it that way. So just to review, I've got the distributive property and then FOIL here. So distributive property is where you have something on in front of parentheses and then you're multiplying it through. And then FOIL we use when we have two sets of parentheses with two things in them, and then you're doing first, outside, inside, and last. So we are reversing that. So we're going from the right side to the left side. So you have things that are already multiplied, and then you're pulling out what's common and putting it in front. And so when we're going to be factoring out the greatest common factor, we are specifically only reversing the distributive property. So we're going to be pulling one thing out and kind of putting it in front. So the greatest common factor, which we abbreviate GCF, is, so we've got the word greatest, so it's the largest. And then we've got common, so that means it's part of every term that we have, and then factor, something that is multiplied in there. So when we think about factors, they're things that are multiplied together. The other way is the opposite, is that you can divide it out. So the greatest common factor is the largest thing that you can divide out of every single term. So that's how you take greatest common factor. That's what it is. So when we did prime factorization way back in week 1, when I have videos on simplifying fractions, we used prime factorization to kind of help us simplify fractions by figuring out what numbers are in common, what you can cancel out. That's where you can do that same thing to find the greatest common factor of numbers, because we're thinking of numbers that are divided evenly into something else. So these are factors. When we have variables, we're always looking at the exponents. And so our greatest common factor generally is going to have a number and variable parts. It's going to be both. And so you have to find it first before you factor. So to find it, first you need to find the greatest factor out of all the numerical coefficients. So you're looking for the largest number you can divide out of all of the coefficients, all of the numbers that you have in each term, the numbers in front. And then once you found that, then you're looking at your variables. And so you want to look at each variable that you have, because you may have more than one variable in a term. And your greatest common factor is the one with the smallest exponent. And if you have variables and they're not in every term, then it's not you can't factor it out, because it has to be in all of them. That's what it means, common. And so you have to make sure you're just looking at the variables that are present in every single term you have. And then when you're looking at that, you look at the one with the smallest exponent on it, and that's the one that is the greatest common factor. So we've got two steps that you can do to factor out, or two methods to factor out the greatest common factor. And so there's the method that the book teaches, and then there's the method that is an alternative that you can do. So the book method and the alternative method, which is my method, basically, they start out the same way, where your first step is you have to figure out what the greatest common factor is before you can factor it out. It's the second step and the third step that are different. So the second step requires you, from the book, is to rewrite each term as the product of your greatest common factor and then something else, basically what's left over and what you need to multiply it back to the original thing. And then you're basically reversing the distributive property. So what this means is, let's say you have some, I'm going to just kind of hypothetically with numbers. So let's say you have two things, A plus B, they're just representing something with numbers and variables. Let's say you found that the greatest common factor is like C. You're taking A and you're splitting it into C times something that equals A. So let me actually just do this with numbers. So let's say I've got 4 plus 8. So we'll just look at numbers. And I know I can divide those both by 4. So that would be my greatest common factor. So basically what it's saying is you're rewriting it as your greatest common factor by something else. So 4 is 4 times 1 and 8 is 4 times 2. So your greatest common factor is whatever you can divide out, the biggest thing you can divide out of those numbers. So that's what it means, rewrite as the product of the greatest common factor and then something else. It's whatever else you need to multiply it back to the original. And then you use the distributive property to remove that. So that means that 4 is in front, and then we would have 1 plus 2. It's kind of undoing the distributive property where what's on the outside multiplies towards the inside. So that's essentially the book method, is you're taking what you have, you're rewriting it, and then you're undoing the distributive property. My method starts the same way. So we'll use the same example, which is usually we, have variables in here, but we'll just use these numbers 4 plus 8. And I can divide those both by 4. So my method is where you take whatever you're dividing by in front, and then you're dividing each of these by the greatest common factor. And then you're simplifying inside the parentheses. So 4 divided by 4 is 1. 8 divided by 4 is 2. You get the same thing. It's just, instead of thinking, writing them as factors as things multiplied, I do it as division. And these are equivalent because, like on the right side, if I'm dividing by 4, I'm also multiplying it by 4. So it kind of cancels out. I'm not actually changing what it's equal to. I'm just rearranging. It's like I had this 4 plus 8, and I'm multiplying it by 1, but instead of writing it as 1, I wrote it as 4 over 4. It's still equal to 1. And then I just, because multiplication, order of multiplication doesn't matter, it's like you're flip-flopping where the denominators are, because when you're multiplying fractions, you multiply straight across. And then that allows me to write it in this alternate form. So these are equivalent methods. It's just a matter of, which method makes sense for the way that your brain works. Whether it's taking what you have and splitting up into multiplication, or taking what you have and doing division, but they come out to the same thing. And both of these are, the goal is to reverse the distributive property. So, I'm going to do a couple where we do both methods, and then whichever method you find easier, we can stick with that method going forward. I think most people prefer the method on the right as opposed to the method on the left. That's certainly what I prefer, which is why I use the one on the right, but we can do either one. So I'm going to just start with a couple examples showing how these methods work and how they basically mean the same thing. So we have 3x minus 6y. So you're trying to find the greatest common factor from 3x and then the 6y here. So that's the first step, is the same for either one. So I'm going to just do it kind of above here. So you start with the numbers and you say, okay, what is the largest number that I can divide 3 by and 6 by? So the largest number that you can divide both of those by is 3. 3 goes into 3 and 3 goes into 6. So I can't divide by, I can't do anything bigger than that because then I start getting fractions. So your greatest common factor has a 3, and then you look at the variables. So you have to have something in common. There's an X in one of them, but not in the other one. There's a Y in one, but not in the other one. So they don't have any variables in common. So your greatest common factor is just a number. It doesn't include any variables. So our greatest common factor is just 3. So the way the book method works is that you start with what you have, 3x minus 6y. And then you're rewriting this with your greatest common factor in front, and then whatever you need in parentheses to get back to your original thing. So for 3x, if I have the 3 separated out, then I just needed x to get to 3x when you multiply that out. The 6y, in order to get to 6, I have 3. So now I need to multiply it by 2 to get up to 6. And then I need to include the y in order to get the y in there. So you're writing it as multiplication. You're kind of taking that 3 and writing it separately. And then you have to kind of fill in the blank to see what do I need to get back up to what I started with. And then because you're reversing the distributive property, you see what's in common here, which is that GCF, reversing the distributive property means that that essentially goes in front. And then in parentheses is what's left over, x minus 2y. As the distributive property would say, if we go the other way, you're doing 3 times x and then 3 times 2y. So you're reversing that, you're kind of pulling it out. So you can always check your work when you're factoring by going back through and multiplying it back out to see if you get to where you were originally are. So I'm just going to keep color coding there that you can see that GCF is now in front. And so when you factor out the GCF, your answer should look like the start of the distributive property. And that's your final answer when you're told to factor out the GCF. Now, sometimes you're told to factor completely. You may have more steps after that. But if all you're doing is factoring out the GCF, that's where you're going to end. Is we've got something in front, and then kind of what's left over is in the parentheses. Now, my method, start at the same thing, 3x minus 6y. And usually what I do is I write this as plus negative 6y, just to kind of avoid any possible sign errors. In this case, it's not going to matter, so I'll just leave it as minus 6y. But I do usually turn into plus a negative when I'm using my method. And so I write my GCF in front. And then in parentheses, I take what I had, 3x, and I divide it by my GCF. And then I have my minus, and then I have my 6x, and I divide it by the GCF. So I have the 3 in front and the 3 in back, so they kind of cancel out eventually. You know, they're equivalent. But I'm basically just dividing what I have by my GCF. And so then I simplify, so I do that division. So I have 3 in front, and then 3x divided by 3. So 3 divided by 3 is 1, and then I'm left with just the x, minus 6 divided by 3 is 2, and then I have y. So you get the same answer, and you're basically doing the same thing. When you're doing the book method, you have to kind of do this division in your head to figure out what goes in the parentheses. Like when we were splitting up that 6y, I had the 3, and then I had to think, okay, what times 3 gets me 6. You can also think about it, okay, 6 divided by 3, what's left over to 2, so that's what goes in parentheses. So you're kind of doing the same sort of thinking, the same sort of operation. It's just how are you looking at it? You're what times what gives me this versus this divided by this gives me this. So you get the same answer, but it's just a matter of how you prefer to think of it. What's easier for you? Is it easier to think about it in terms of multiplication or division? But in my head, when I do the book method, I usually do division in my head to figure out what goes in the parentheses. So I might as well just write that division and do that and get the same answer. So that's how you would factor out the greatest common factor here. This is, you're finding what's in common, you're pulling it out, and then you've got what's left over once you've divided that out. And that's the second factor. There are questions on either this book method or the alternative method here, or the problem in general. Okay. So I'll do another one with both of the two methods so you can see. So we've got 5a cubed plus a squared b. So our first step is to find the greatest common factor. So you first look at the coefficients. So we have the number 5, and then the a squared b doesn't have a number, so that's 1. And there is nothing in common that I can divide out of 5 and 1 other than 1. And so you generally don't write that, dividing by 1 isn't going to mean anything. So we don't have a number in common between our coefficients. So then we move on to the variables. And so both terms here have an a. And so you take the smallest exponent. So first term has an exponent 3 on the a. Oops, just dropped my pen. Second term has an exponent of 2 on the a. So the smallest exponent, 2, is smaller than 3. So our greatest common factor is going to have an exponent of 2 on the a. And then we have a variable b, but it's not in both terms. It's not in common. So that's not part of the greatest common factor. So our greatest common factor is going to be a squared. So book method, we have 5a cubed plus a squared b. And so you want to rewrite each of these with your greatest common factor in front, and then in parentheses is what you need to multiply that by to get back up to the original. So a squared, we have to multiply by something to get to 5a cubed. So I don't have a number. I need to have a 5 in the parentheses to get to the 5. And then I have a squared, but I need to get to a cubed. So I need another a, because a squared times a will get me a cubed. There's now 3 of them. Second term here, we have a squared b. So I've got my a squared. So in order to get a squared by b, I need to multiply by b. So now I've kind of figured out what goes in the parentheses, how I've split this up. And now we're reversing the distributive property. So they both have a squared in common. And then, so when you pull that out, you're left with 5a plus b. Basically, what is left in the parentheses. So this method, this is essentially what we do for grouping. So I'm going to just write that down. This is similar to grouping. So there's a factoring method called factoring by grouping. And you have it rewritten so that your exponent or your greatest common factor is in front. You pull that, those get pulled out. So you put the greatest common factor in front, and then in the second set of parentheses is kind of your leftovers. So when I am factoring by grouping, I'm basically using the book method. But in order to get to the part where I can use the book method, I still use the alternative method. And you'll see this when you go into the factoring by grouping video. You'll see how I kind of actually use both of these methods, but I do the alternative method first and then the book method after that, because you're essentially factoring by grouping is factoring twice. And so I use both methods here. But when I'm factoring out the greatest common factor, I usually don't use the book method. I use the alternative method. So doing the same problem with the alternative method, we have 5a cubed plus a squared b. And so I write my greatest common factor in front, a squared, and then I divide each of these by that greatest common factor. So I get a squared in front, and then I simplify. So I've got a 5, and then I use the rules of exponents, where when you've got division, you subtract your exponents. 3 minus 2 is 1, and so that's how I know that I have a single a there. And then the a squared over a squared cancels, and so I'm just left with a b. So we get the same answer both ways. We've got the book method where you have to kind of think about what you're multiplying by, and then the alternative method, you're dividing it out. So I find the alternative method easier when I'm dealing with variables, because it's harder to kind of figure out, okay, I've got an a squared, I have to get to a cubed, what do I need to multiply by? It's a little harder to think about that. You can do it in numbers, like when we were trying to create the 6, 3, okay, 3 times 2 gives me 6, like with numbers, it's pretty easy to do in your head. But when it comes to variables, it's usually a little more difficult. I find it's easier to do the alternative method because then all I need to do is subtract exponents, and that tells me what I needed. So it just seems a bit mentally easier. So that's why I tend to do the alternative method. So are there any questions on this example, or, do you have an opinion on which method you prefer? If there's no opinion on the method, I will just do it the method that I usually do. So I'll just do the alternative method each way. So not hearing or seeing anything. So that's what I'll do. So now we're told to factor out the greatest common factor. So directions are important. When it says factor out the greatest common factor, it's telling you need to reverse the distributive property. So you have to do more than find the greatest common factor. You have to actually pull that out as well. But your first step is to find the greatest common factor. So on the left, I have 4p plus 12. So I need to find my greatest common factor. So I look at my numbers, 4 and 12. And then what is the biggest number I can divide out? So I can divide those both by 4. I can't divide it by anything bigger than that. And then I've got p and then something without a p. So they don't have any variables in common. So my greatest common factor is just the number 4. So we have 4p plus 12. And to use my method, you put your greatest common factor in front, and then you divide each term by the greatest common factor. So we're going to have 4p divided by 4, and then the plus sign, and then 12 divided by 4. And then you are going to do the division in the parentheses. So 4 divided by 4 is 1, so I'm left with 1p, which I could just write as p, plus, and then 12 divided by 4 is 3. So you get 4 and then parentheses p plus 3. Now, when I'm doing problems where my greatest common factor is just a number, I encourage you to get to the point where you can do that mentally, so you can skip that middle step and go straight to the final answer. because you're just dividing the numbers by, whatever your greatest common factor is. So you can just do that easily mentally or with a calculator to do the division. And it just kind of saves you some time, especially if you're really good with your multiplication and division, you have less to write down. So I do encourage you to get to the point where you can find the greatest common factor and factor it out mentally. But sometimes things are a little complicated and you can't factor it out mentally. And so you do want to show that step. But because factoring is so important, the more you can do mentally in your head, the faster it will be. And then the better off you'll be once you get to college algebra, because college algebra, you do factoring a lot, and then you have a lot more steps after you do the factoring. So if you're slow on the factoring, you're going to be slow on the whole problem. And when you've got a long problem, you're going to run out of time. So you really want to get to the point where you can do this mentally, basically do the division in your head mentally. So just think about that, try to do it. But if you can't, show that step so that you know what's going on. The next problem here, I have 16d cubed plus 24d squared plus 32d. So we have three terms, but when you're factoring out the greatest common factor, you're doing the same thing. So first, you want to look at the coefficients. So we've got 16, 24, and 32. And you're looking for the biggest number you can divide those all by. So knowing your multiplication tables helps because it helps you quickly find out what the greatest common factor is. And so 16 goes into 32, but it does not go evenly into 24. So I know that 16 is not the greatest common factor. But 8 I can divide into 16, 24, and 32. So 8 is going to be the biggest one that I can factor out. So the way I do this mentally is I take the smallest of the coefficients and then I start thinking of the numbers that divide into it, going from the biggest to the smallest, and try those mentally in my head. So that's why I started with 16. 16 didn't work. And I'm like, okay, the next number that divides into 16 is 8. That's the next largest one. And so that's how I figure out the greatest common factor. So 8 goes into all three of these, and that's larger. Then 4 also does, but it's not the greatest. So that's not going to be, if you use 4, you're not going to be done. You're not going to get the right answer because you want to use the largest one. Then I look at my variables. So they all have a d. The first term has d cubed. Second term has d squared. And the third has a single d, which would be an exponent of 1. So the smallest exponent is the single d with an exponent of 1. So I can factor out a d. So my greatest common factor is 8d. So I've got my 16d cubed plus 24d squared plus 32d. And I'm going to factor out an 8d. Keep writing a. 8d. Which means I'm dividing 16d cubed by 8d. And then I have a plus. And then I'm dividing the 24d squared by 8d. And then a plus. And then 32d divided by 8d. So I have my 8d in front. 16 divided by 8 is 2. And then a single d has an exponent of 1. So 3 minus 1 is 2. So I get a d squared. Then 24 divided by 8 is 3. And I have a d squared divided by a single d. So 2 minus 1 is 1. So I'm left with a single d. Then 32 divided by 8 is 4. And the d's cancel. D over d. That's 1 minus 1, which is 0. So it's not there. And so your final answer is 8d in front. And then in parentheses, you have 2d squared plus 3d plus 4. And whenever you end up with something inside the parentheses that has like an exponent of 2, there's a potential to factor further. But we're just focusing on only factoring out the greatest common factor. So no, we're not looking at going further at this point. We just want to practice this step, which is reversing the distributive property. Are there any questions? Okay. So left here, I've got y squared minus y cubed. So generally, we like to have the largest exponent be written first. So if we have y squared minus y cubed, you would write this as y squared. And then I write it as plus a negative y cubed, so that I can see that when I put my highest exponent first, I have a negative in front. So it's a negative y cubed and then y squared. So just conventionally, when you're writing these things, if you have something with an exponent, we want the highest exponent first. So now we're factoring out the greatest common factor. And generally, when you have a negative in front, you want to factor out a negative, because we just like to have positive things. And when we, the first term of something, we like to have a positive. So if it starts out with a negative, we don't like to actually have that negative there. So we just include a negative when we're factoring out a greatest common factor. So our greatest common factor is going to have a negative, and then we look at the exponents, and we've got a y cubed and a y squared, so I can factor out a y squared. So I'm going to just start by, because I know I'm going to need more room here, so I'm going to start by rewriting. So I've got negative y cubed plus y squared. And so I want to factor out a negative and then a y squared. And so I have a negative y cubed divided by a negative y squared plus then a y squared divided by negative y squared. So I have a negative y squared in front. And then in the parentheses, negative divided by negative is a positive. So we like to have inside parentheses, the first thing be positive. And then I subtract my exponents. 3 minus 2 is 1. So I'm left with a single y plus. And then I've got a positive divided by a negative. That's going to give me a negative. So you can turn that plus into a minus. And then y squared divided by y squared, that cancels out. You're left with 1. So if there's no number there, you have to put a 1. You can't just not write anything there. And it's not a 0 because you're dividing. So if you're dividing by the same thing, it equals 1. It doesn't equal 0. So while the exponents subtract to 0, y squared minus the 2 minus 2 is 0. Anything to the 0 power is 1. So you actually have a 1 there. And so your answer is negative y squared, and then in parentheses, y minus 1. So we like to have, when you have parentheses, we don't like that first thing to be negative. Now, if you did not rearrange, so if you didn't rearrange it with the highest minus the lowest, you would be factoring out a y squared instead of a negative y squared. And what would happen is that instead of y minus 1 in parentheses, you would end up with 1 minus y, which is also okay because you can see that the first term there does end up being positive. So that's okay as well. And so sometimes that is the preferred way to do it. It kind of depends on how you're using things, but generally we like to have the largest exponent first. But this is equivalent. These two answers, they are equivalent, so they mean that they essentially are both correct. But we generally use the first one, especially because when we use factoring, the first one ends up being more useful than the second one. So that's why we generally always put the highest exponent first and then factor, just for the reasons that we use factoring. And it becomes more useful. So the second example I have here, we have 7r cubed minus r to the fifth plus r to the fourth. So same thing, we like to have the exponents in descending order, so the highest to the lowest exponent. So we would actually rewrite this so we have a negative r to the fifth in front, because that's the highest exponent, and then plus r to the fourth, and then the 7r cubed, because we just like to have highest exponents to lowest exponent. And this is just because it's more useful. So this is why we do that. So again, we have a negative in front. So we're going to factor out a negative. And then out of the r's, the smallest exponent is 3. So I can't factor out a number because only one of these has a number, which is 7. And I could only factor out a 1 out of all these for the numbers. So we're going to have a negative r cubed. So I'm going to divide each of these by negative r cubed when I write my factoring. So I have negative r to the fifth divided by negative r cubed plus r to the fourth divided by negative r cubed plus 7r cubed divided by negative r cubed. So I get negative r cubed. Then a negative divided by negative is a positive, and you subtract your exponents. 5 minus 3 is 2, so I get an r squared. Then I have a positive divided by negative, which is a negative, so I have a minus sign. And then I subtract the exponents. 4 minus 3 is 1, so I have a single r. And then I've got a 7, and this is basically divided by negative 1, so that's a negative 7. And then the r cubed, 3 minus 3 is 0, so I don't have an r, but I've got a number, so that's fine. So we end up with r squared minus r minus 7. Now, if you did not rearrange it, and you would end up only factoring out a positive r cubed, and you would end up with instead 7 minus r squared plus r, if you didn't rearrange it the way that we did it. So both of these, again, are equivalent. But in general, the top one is more useful for things that we have to factor for in order to do other stuff. And so we generally do the first one versus the second one, but they are equivalent and both are correct. So, but I encourage you to get into the practice at the top by rearranging, just because that is the one that's useful later on. So are there any questions on either of these two examples? Okay. All right, so now we're going to do some more complicated ones with multiple variables going on here. So on the left, I have 5u cubed v squared minus 5uv. So when you've got multiple variables, we generally don't bother trying to rewrite it if we need to, because it's kind of hard, you know. In this case, both of the highest exponents are the first term, so it's totally fine. The one on the right, which I noticed that when I typed it, I accidentally have something in the exponent that shouldn't be in the exponent. That n is not in the exponent. So that should be n squared. The n is not in the exponent. On the right, it's like, well, do I put the m with the highest exponent first, or do I do the n with the highest exponent first? So if you've got multiple variables, we usually don't worry about the order that it's written in. It's usually if we have one variable. So let's look at the one on the left. So I've got my 5. I got a 5 in both of these. So I need to find my greatest common factor. And trying to get my pen. Here we go. So, oops, I accidentally changed slides somehow. Okay, greatest common factor. So I've got a 5 in common that I can divide out because they both have a 5. And then I go each variable individually. So I look at the u's. I've got u in both terms. One of them is a u cubed and another one is a single u. So smallest exponent would be the single u. So my greatest common factor has a u. And then v, I've got a v squared in one term and a v in the other term. So v's in both of them, but I take the one with the smallest exponent, which would be the single v. So my greatest common factor is 5uv. So I'm going to put that in the front, and then I divide each term by the greatest common factor. And I just make sure that my u's and v's look different so that I don't get confused. So when I actually do the division, 5 divided by 5 is 1. You can write the 1 if you want. I don't if I'm going to have more things written there. U cubed over u. So the u has an exponent of 1. So you get a u squared. And then the v squared over v. When you simplify that, you get a single v. So I get u squared v minus. And then I have 5 over 5, which again divides to 1. And this time I will write the 1 because I noticed that the u's and the v's are going to cancel. So everything's going to cancel. So I have to write a 1 there so that I have something actually there. So we have 5uv and then in parentheses u squared v minus 1. Now on the right, I have this more complicated thing. So I look at the numbers here and we're not going to rearrange it because we've got multiple variables. It's kind of hard what order would you put it in? So I've got 8, 24, and 4. So I look at the smallest coefficient, which is 4. And I can divide 4 out of all these terms. So that's going to be the largest thing I can divide out. I can't divide anything bigger than 4 because then I'm going to get a fraction in that last term. So my greatest common factor is going to include 4. Then I look at the variable. So I have m squared, and then m cubed. So the smallest exponent on the m is a 2. And then I look at the letter n, and I've got an n cubed, n squared, and then n. The smallest is a single n. So my greatest common factor is going to be 4m squared n. So I'm going to factor that out. I'm going to put this in front and then divide each term by that greatest common factor of 4m squared n. I've got a minus, and then 24m squared n squared divided by 4m squared n, and then plus 4m squared n, 4m cubed n divided by 4m squared n. And always be careful that you haven't forgotten anything, that you've written it all correctly, because it's when you've got so many things that you're writing down here, it's easy to like write the wrong number or something like that. So you just want to be very careful and double check everything. So I've got 4m squared n, and then in parentheses, I start simplifying. So 8 divided by 4 is 2. M squared over m squared completely cancels. And then n cubed over n becomes n squared. So I've removed an n. Then I'm minus 24 divided by 4 is 6. M squared over m squared, those cancel. N squared over n becomes a single n. And then 4 divided by 4 is 1. And my variables don't cancel, so I'm not going to write the 1. M cubed over m squared gives me a single m. And then the n's cancel. So that is the answer after you've factored out the greatest common factor. We have 4m squared n, and then in parentheses, 2n squared minus 6n plus m. Are there any questions? Okay. So left here, I've got 100 a squared to the fifth b cubed plus 16 a squared b. So I need to figure out the largest number I can divide out of 100 and 16. So I'm going to look at the 16 and first say, okay, can divide 16 out of 100. And that's a no, but you can use your calculator. You're basically doing 100 divided by 16 and then seeing do you get a whole number. But you don't, you get 6.25. So if you don't get a whole number, you can't divide it out. So then I'm like, okay, what's the next number I could divide out of 16? Well, 8. So then does 8 go into 100 evenly? No. So then I'm like, okay, what else can I divide 16 by? 4. Can we divide 100 by 4? Yes. So 4 is going to be the number I can divide out of 116. Then on my a's, I have an a to the fifth a squared. So the smallest exponent is 2. So it's going to be a squared. And then I have b cubed and b, smallest exponent is b. So our greatest common factor is 4a squared b. So I'm going to factor that out. So I put that in front. And then in parentheses, I have 100 a to the fifth b cubed divided by 4a squared b. And then plus 16a squared b divided by 4a squared b. And then I do my division. 100 divided by 4 is 25. A to the fifth divided by a squared. So you subtract your exponents. 5 minus 2 is 3. So it's going to be a cubed. And then b cubed over b, b minus 1 is 2. Or 3 minus 1 is 2. So you get b squared. Plus 16 divided by 4 is 4. A squared over a squared cancels. B over b cancels. So we're left with just plus 4 there. So you get 4a squared b. And then in parentheses, 25a cubed b squared plus 4. On the right here, I've got 4 terms. So it doesn't matter how many terms you have, you're still looking for your greatest common factor before you can factor it out. So I'm going to look at the numbers first. So I have a coefficient of 1, 5, -2, and then 8. So if any of these have a coefficient of 1, there's no number you can factor out. So because I don't have a number in the first term, there's no number I can factor out here. So then I go with my variables. I got the letter u. So I've got a u squared, u cubed, u squared, and then u. So the smallest is a u. So I can factor that out. Then I go to the letter v. I've got a v squared, a v squared, but there's not a v in my third term. So as soon as it's not in one of the terms, it's not part of the greatest common factor. So because that minus 2u doesn't have the letter v, I can't factor it out. So my greatest common factor here is just the letter u. So I have u, and then in parentheses, I'm going to divide each of these by u. So I have u squared v over u plus 5u cubed v squared over u minus 2u squared over u, and then plus 8uv over u. So when I start simplifying, I'm basically removing a u from each of these terms. So the u squared v becomes uv, because there's one less u, plus 5 u squared v squared minus 2u plus 8v. So you've basically, when you're factoring out a u, you are dividing a u out. You're removing a single u from each term. So each of the u's becomes one less. And then if there is only a u in it, it basically disappears. Any questions? All right. Final examples here. So I've got 15 m p to the 7th q to the 4th plus 12 m to the 4th q. So greatest common factor. So out of the 15 and the 12, I can divide those both by 3. That's the largest number. They both have m. I have an m and an m to the 4, so I can divide them out by an m. I have a p to the 7th, but there's not a p in the second term, so I can't factor that out. But they both do have q. One's a q to the 4th and one's a q to the 3rd. So the smallest exponent is 3, so I can factor out q to the 3rd. So I have 3m q cubed divided by 15m p to the 7th q to the 4th over 3m q to the 3rd plus 12m to the 4th q to the 3rd divided by 3m q to the 3rd. So 3m q cubed. 15 divided by 3 is 5. M's cancel. I have a p to the 7th. And then q's, 4 minus 3 is 1, so I have a single q. Then 12 divided by 3 is 4. M to the 4th over m, 4 minus 1 is 3, so I have m cubed. And then the q's cancel, 3 minus 3 is 0. So you have 3m q to the 3rd times 5p to the 7th q plus 4m cubed. Now, last one here, greatest common factor. So I've got w cubed minus 5u cubed v. So I've got no number I can factor out because I have a 1 in front of the w cubed. So I can't, there's no number in common. I've got a w, but it's not in the second term. And the second term has u and v, that's not in the first term. So there is nothing in common between these. So that means there's no greatest common factor. The greatest common factor is basically just 1. And when that happens, we call this prime. When you can't factor it, when there's nothing to factor out. So we're told to factor out the greatest common factor. We can't because there is no greatest common factor. So there's nothing you can do. Your answer is what it is. It's w cubed minus 5u cubed v squared. But we usually say prime, meaning that there's nothing in common here. Now, when we get to other types of factoring, you may have no greatest common factor, but you can still do a different type of factoring. And if that is the case, then it's not prime. So it's just because there's no greatest common factor doesn't mean it's always prime. But in this case, it is because we're told to just factor out the greatest common factor, not to do other types of factoring. And so there's nothing more that we can do because there isn't a greatest common factor. So we would say prime in this case, but sometimes there's a different type of factoring you can do. And as long as you can do some sort of factoring, then it's not prime, but this one is. Are there any questions? Okay, so that is the last of my examples. So this is factoring out the greatest common factor. When you go to the next step of factoring, that's factoring trinomials and those kind of things. You always try to factor the greatest common factor out first before you go to factor further. So there's like a hierarchy of factoring, but you always do GCF first and then go down, try to factor after that. So if you run into any issues when you're factoring, or if you have questions, of course, you're able to ask me. And hopefully this helps. You know, if you're confused about how even finding the greatest common factor, I do have a video on how to do that, to find that in more detail. You really want to be able to do this mentally, find the greatest common factor in your head, and then be able to kind of do this factoring out in your head, because once you get into the more complicated factoring of trinomials, that, you know, you may have more steps to do. And so doing as much as you can in your head mentally is usually quicker and it will save you time.